Let us now go ahead and talk about alpha and beta. Okay, so these ones we call them roots of the quadratic equation. So I have this question, which is saying given that the roots of the quadratic equation is x squared minus 4x minus 2 is equal to 0 are alpha and beta. Find the values of whom. So this question is very important for you to know it. It came in an exam 2 years ago. So expect this question to come in your test and the exam as well. Okay, so don't take this question for granted. These are the most important questions that every student should take note of. It's very important. So the first thing is we need first to find the sum and product. So the sum alpha plus beta is given by negative b divided by a. Then alpha times beta, which is the product, is given by c over a. This is a, this is b, and this is c. What I mean is a is 1, b is -4, and c is -2. So then alpha plus beta is equal to, I'll say negative, then b is also -4, then divide it by a is 1. So therefore alpha plus beta is basically equal to 4. I leave it there. Alpha times beta, c is -2 over 1, so alpha times beta is basically -2. That is something that is very important. We have to take note of that. So you need to find first the sum and the product. Okay, so then these things, let me just shift them to be on top there. Okay, and I no longer need this. Now I need to rewrite this in a such a way that I need to have alpha plus beta and the alpha times the beta. Then if I write them in that way, it's going to be easy for me. Okay, so let's go ahead and do that. So then I know that alpha plus beta then divided by beta divided by alpha. The common denominator is alpha beta. Beta into beta, beta will cancel out, so I'll have alpha squared. Alpha here, I'll have beta squared. Whenever you are going to come across alpha squared plus beta squared, there's a formula that we have to replace, but I'm going to derive for you. So then I should also take note that this is going to give me, we should take note that this is the same as, I can write that to be alpha plus beta raised to the power 2 being equal to, if I'm to expand this, it's going to be alpha times alpha is alpha squared, alpha times beta is alpha beta, beta times alpha is alpha beta, beta times beta is beta squared. So then alpha plus beta raised to the power 3 should be equal to alpha plus, I'll put beta here squared, alpha squared. So this and this can be added, giving me 2 alpha beta. Our goal is to find what alpha squared beta squared is. I'll shift this to go to the other side. So alpha plus beta raised to the power 2 minus 2 alpha beta should be equal to alpha squared plus beta squared. So wherever you are going to be solving these questions and to find alpha squared plus beta squared, you should always be replacing it with alpha times beta, then 2 alpha beta. That's what you need to know. So then I can get rid of this. So you don't need to derive the formula, but just know that you are supposed to replace that with that. So the same applies here. Here I'm going to replace with alpha plus beta squared minus 2 alpha beta. The reason why we do this is because I don't know what alpha squared is, alpha squared plus beta squared. I have to make it in such a way that I need to find alpha beta and alpha times beta and alpha plus beta. This one we found it -2. Then from here now we can plug in the values. Alpha plus beta is 4, but we square it 2, that is also -2. I divide it by -2. Okay, so let's see, that is going to be 16. So 16 minus, what else are we going to have? We are going to have 16, then we have 4 squared is 16, right? Minus 2, then that is going to be plus 4 divided by negative 2. Okay, so if I divide that by negative 2, what do we expect to have? We can clearly see that we are going to have now 2 into, this is going to be 20 divided by negative 2. The answer becomes 10. So that's the answer for this question. Then I should also go ahead and also talk about part B. Now remember, we are from expanding this, but now here we are talking about this guy, x raised to the power 3. Okay, so x raised to the power 3, what we are supposed to understand now is very simple and straightforward. Let us see. So what we are going to have is I have first to expand this, of which I know that first I need to expand. What I'm trying to tell you is I need first to expand alpha plus beta raised to the power 2, and also alpha plus beta, meaning, so now we already know what alpha, what this is, that is that. Okay, but remember we say that this one, after expanding, we are shifting now this to go to the other side, which is going to be alpha squared plus beta squared, then plus 2 alpha beta. So we are multiplying this by alpha times beta. So if I do this one by one, we realize that we have alpha times alpha is alpha to the power 3, alpha times beta is alpha beta squared, then alpha times that is going to be 2 alpha squared beta. Then let me just shift this one a bit this side to create space. Now I'll start with beta. Beta times alpha squared is alpha squared beta. Beta times beta is plus beta to the power 3. Beta times 2 is 2 alpha beta squared. Now the things that are raised to the power 3, put them together. So this and this, they will be here. Then now there's also this guy here raised to the power 2, and also this guy raised to the power 2. So they can be added, and I'll end up having 3 alpha beta squared. At the same time, this guy is raised to the power 2, and this guy can also be added, and we'll have 3 alpha squared beta, like that. So remember, we are trying to make this guy as a subject of the formula. So what we will do now, what we have now is alpha to the power 3 plus beta to the power 3, then plus 3 alpha beta squared, squared, plus 3 alpha squared beta. So now our goal is to make alpha to the power 3, beta to the power 3 as a subject of formula. Shift this, so I'm shifting now these to go to the other side. So then I'll have alpha plus beta raised to the power 3 minus 3 alpha beta to the power 2 minus again 3 alpha squared beta should be equal to alpha to the power 3 plus beta to the power 3. But now in this case, since there is a square here and there is a square here, I need to factor out to make things simple. So alpha plus beta raised to the power 3, I can factor out negative 3 alpha beta, and here I'll remain with, it's going to be positive now, I'll remain with beta squared plus then alpha. It's not going to be beta squared, but beta, only one beta and plus alpha. But these ones can be written as alpha plus beta raised to the power 3 minus 3 alpha beta. Then since it is positive, nothing is going to change. I can start with alpha plus beta, like that. So wherever you are going to find a function asking you to find alpha plus beta, so this is equal to alpha to the power 3 plus beta to the power 3. Wherever you are going to find alpha to the power 3, alpha to the power 3 plus beta to the power 3. You always replace by a function. You're not supposed to derive, but you need to know this function. It's the one I'm telling you about right now. Let me just put it down here because I don't have enough space. So it's alpha to the power 3 plus beta to the power 3 is equal to alpha plus beta raised to the power 3 minus 3 alpha beta open brackets alpha plus beta. So you always replace with that. So don't even stress yourself. You always replace with that. So now the second question here, we're trying to find the same things. So we just plug in the values. Alpha plus beta is 4 raised to the power 3 minus 3 alpha times beta is negative 2. Then alpha plus beta is 4. So 4 raised to the power 3, that should be 64 minus, so negative and negative will cancel. I'll have 6, that is going to be 24. So 64 plus 24, that should be 88. So 88 is the answer for this question. Now you can do the same for the rest of the questions. It's something that is not complicated. Let's go and do part C. So you can pause the video, try to work it out. Yeah. So this one, if you try to expand this, what are we going to have? Let's see. So alpha minus beta raised to the power 2. If I expand, this means that is alpha times alpha is alpha squared. Alpha times this is going to be negative this. Negative beta times alpha, negative alpha beta. Beta times beta is going to be beta times negative beta times beta is positive that, and I'll end up having alpha squared plus beta squared, then minus this is going to be 2 alpha beta. And remember, wherever you see this, you replace it with that. So I'll do that. So it's now alpha plus beta squared minus 2 alpha beta again minus 2 alpha beta. So now these things are the same. They can be added since it's minus minus. That would mean to say it is negative 4 alpha beta. Now I can plug in the values here. So I'll do it from here. Positive, the sum is 4 squared, 4 then negative 2. So I'll have 16 plus this 2 will give me 8. 16 plus it should be 24. So 24 is my answer for that question. Okay, let us go ahead and also do part D. So part D, we have 1 divided by alpha squared plus 1, then plus 1 divided by beta squared plus 1. The common denominator is alpha squared, okay, plus 1. Then here beta squared plus 1. So if I expand this, or not really expanding, what I'm going to do is this one here I'll remain with beta squared plus 1 plus this one here will cancel out, and I'll remain with alpha squared plus 1, like that. So then on top there we can clearly see that we have just alpha squared plus beta squared. 1 and 1 is going to give me 2. The denominator now I can't work out the way they are, then I have to expand alpha times okay, I need to expand this now. Alpha squared times beta squared is going to be alpha squared beta squared. Alpha squared times 1 is alpha squared, then 1 times beta squared is beta squared. 1 times 1 is 1. That means that is alpha squared. Remember, where there is alpha squared we replace with what? Don't forget, where there is alpha squared I'm going to replace that with this. So it will be replaced by alpha plus beta raised to the power 2 minus 2 alpha beta plus 2. Divide it, then this is the same as just alpha beta raised to the power 2. Then plus, where there is alpha, this alpha squared plus beta squared will replace it with 2 alpha plus beta squared minus 2 alpha beta then plus 1. Now we can go ahead and plug in the values. So what is alpha plus beta is 4 squared minus 2 alpha times beta negative 2 plus 2 divided by alpha times beta negative 2, but you square it, plus that is 4 squared minus 2 negative 2 plus 1. What are we going to have? That will be 16. Negative and negative will be, so we'll have this. Denominator we have 4 plus 16. Negative and negative will be positive. 2 times 2 is 4 plus 1. 16, 20, 22 over, that will be 20, 24, 25. So it's 22 over 25. Okay, so it's 22 over 25. That's the answer. You can do the same. You can also go ahead and do part D. I should leave you with something to answer. Which question can I leave with you? Okay, I'll leave this part for you, because this part is not really complicated. It's similar to part D. Find F, I'm going to find E for you. So E there, let's just go ahead and find the common denominator. The common denominator, it is 2 alpha plus beta, alpha plus 2 beta. So this and that will cancel out, and I'll remain with alpha plus 2 beta. That is going to be here, plus even 1 here will cancel out, and I'll remain with 2 alpha plus beta. So if we are to expand this, what are we going to have? I can now do what? What can I see? I have got alpha plus beta. So what I would do is, I have alpha plus beta. Then this one I'll start with also 2 alpha plus beta. I start writing alpha. So this one I can expand. 2 alpha times that is going to be 2 alpha squared. Alpha times 2 beta is 4 alpha beta. Beta times alpha is alpha beta. Then alpha, this is going to give me now also 2 beta squared. So what do we see? These two, they will remain the same. I can factor, or here there's 2. I can factor out 2, and I'll have alpha plus beta divided by this one for squared and this one for squared. Let them be together. 2 squared, like that. These two can be added and will give me 5. Now we clearly know that alpha plus beta plus 2 alpha plus beta, we clearly know that here I can factor out alpha, or 2. I'll have alpha squared plus beta squared, then plus 5 alpha beta. Now we know where there is alpha squared plus beta squared, what to replace with. So then alpha plus beta plus 2 alpha beta, that is the top part. I'll divide this by 2. Where there is alpha squared, we replace with this one, don't forget. Alpha plus beta squared minus 2 alpha beta. I'll do it like that. Then plus 5 alpha beta. When I reach at this point, now I can go ahead and plug in the values. So alpha plus beta is 4, plus 2 alpha plus beta again is 4. Then 2 alpha plus beta is 4, but we square it, minus 2 alpha times beta is negative 2. Then plus 5 alpha times beta is negative 2. Let us see now the answer that we're going to get. So on top there it will be 8 plus 4, that is 12. Down part I'll have 16 times 2 is 32, plus, because negative and negative will be plus, then 4 again plus. This is going to be negative now, minus 10. So what I have now is 32, that is going to be 36. So I have 12, 36 minus 10, that is 26. So I can now reduce this. 2 here, 2 here 6, 2 here 13. So 6 over 13 is my answer. Yeah, 6 over 13 is my answer for that question. But I want you guys to go ahead and solve part EF and send me the answer in the comment section. Okay. So this is also related to part 2, the one we are from solving. So now they want us to find the quadratic equation with integer coefficient which has the roots of this. Just think of this is alpha, this is beta. That's all. So you always, when you're talking about the equation of this is given by x squared minus, so we have got sum times x plus product is equal to 0. And you guys literally know that sum, it is alpha plus beta times x plus the product is alpha times beta is equal to 0. So the equation that we're going to be following is this. So the sum then times x plus product, that is alpha plus beta, is equal to 0. So what they are looking for is, just imagine that this is alpha, this is beta. The first one is alpha, so the first thing we have to find the sum. So you add this. The common denominator is 12. 3 there, 4, we are going to have 3 times 4. We are going to have 4 times 3 is what am I trying to say? 3 into, it will be 4 times 1, 4. Then here 3. So end up having 7 over 12. So this is the product. So x squared minus, so the product, sorry, the sum is 7 over 12 times x. Let's now find the product, alpha times beta, which is 1 over 3 times 1 over 4. So that will be 1 over 12. Then 1 over 12 is equal to 0. That's the equation. To make this equation to be more interesting, do times 12 everywhere to get rid of a fraction. So it will be 12 x squared minus 7x plus 1 equals 0. This is the equation. Okay. Do the same for the rest of the questions. Let's go to part B. First thing, add 1 minus 4i plus 1 plus 4i. We're just adding. So this and that will cancel out. You have 2. 1 plus 1 is 2. So x squared minus the sum is 2. Let's find the product. Product, we are now multiplying. 1 minus 4i, 1 plus 4i. 1 times 1 is 1. 1 times that is 4i. That is going to give me negative 4i. That is going to give me 16, negative 16 I squared. I'm multiplying now. This times this is this times that is that, this times this, negative 4i times 4i, negative 16i squared. Wherever you are going to come across I squared, replace it with negative 1. So then this will be 0. 1 minus 16 negative 1. So that gives me 17. Because this is going to be positive. 1 plus 16, that is 17. Equals 0. So x squared minus 2x plus 17 is equal to 0. That is my equation. Okay. So let's now jump into part C. So the first thing, add add those two things. So 4 plus 2 root 3 plus 4 minus 2 root 3. This and this will be 0, so I have 4 plus 4, that is, sum is now 8 plus 8, or 4 plus 4, that is 8, x plus now the product. So we are now multiplying these two. Here there is minus 2 root 3. So this question came last year in test 1, so it's something that is very important. You have to know it. This is the one which came, so you need to know it. These are the most important things. 4 times 4 is 16. 4 times that is 4. 4 times 2 root 3 is 8 root 3. Then 2 times that is 8 root 3. Then minus, that is going to be 4. This is root 3. 4 root 3 times root 3 is just 3. So 16, this and this is 0. They will cancel out. I have minus, that is going to be 12. So 16 minus 12, isn't it 4? Yeah, it's 4. So then plus 4 should be equal to 0. That's the equation. Let's go now to part D. First thing, add them. 3 plus I root 2 plus 3 minus I root 2. This minus this is 0, so I'll end up having this sum to have 6 x plus, I don't know the product. Let us multiply them. So we are multiplying these by those. So 3 times 3 is 9. 3 times negative I square root of 2 is 3I root 2. I root 2 times 3, it is what? So I'll still have, let's see. What are we trying to find? Okay, so we are saying 3 times 3, so I've made a mistake here. 3 times 3 is 9. 3 times root I root 2, now root 3 should be negative 3I root 2. Then 3, now this times that is going to give me plus 3I root 2. This times that is going to be minus, it will be 2, because root and root will cancel out, then I will be squared. Remember, wherever you find I squared, replace with negative 1. This and this will be minus, so you have 9 minus 2, where there is I squared, replace it with that. So it's 9 plus 2, that is 11. So then the product is 11, equal to 0. This is the equation they want. As simple as that. Let us dive now into question 4. So remember, for question 2, let's not forget the thing that we were talking about. We said that wherever we are going to find alpha, can I write from here? Wherever we are going to find alpha to the power 2 plus beta to the power 2 should be replaced by alpha plus beta raised to the power 2 minus 2 alpha beta. That's what we said. These are the equations we drive. Wherever we are going to find alpha to the power 3 plus beta to the power 3, we have to replace it with alpha plus beta raised to the power 3 minus 3 alpha beta, open brackets, alpha plus beta. These are the things that we said. If I can take you back a bit, that's what we said is here. Okay, yeah, so we should take note of this. So now, if I don't want to forget about this, then we are now doing the first one. Remember, we need first to find, the question is the roots of the quadratic equation 2x squared minus x plus 6 is equal to 0 are alpha and beta. Find the quadratic equation. Remember, the equation will always be x squared minus the sum, that is alpha plus beta, times x, then plus the product should be equal to 0. But first of all, let's find the sum, alpha plus beta, which is negative b over a. So what is negative? What is b? B in this case is 1, negative 1. So it will be 1, negative and negative will cancel, 1 over 2. Alpha times beta, it is c over a. C is 6, a is 2. So I'll have 3. Okay, let's not forget about that. So then let us now go ahead and first do the we do plus, and then later on we'll come and do we'll multiply them. So alpha squared plus beta, then we are doing plus alpha plus beta squared. So this is now, I can isolate this can come together, then alpha plus beta. So this I've just started writing alpha then plus beta. So we can clearly see that alpha plus beta, as long as there's alpha squared plus beta squared, replace that with alpha plus beta raised to the power 2 minus 2 alpha beta, don't forget, then plus now alpha plus beta. Now we can plug in the values, that is for sum. So alpha plus beta is 1 over 2, but it is squared, minus 2 alpha beta is 3, then plus alpha plus beta is 1 over 2. Okay, let's not forget about that one. So then what are we going to have? The one for sum. Okay, so we have let us see what we're going to have. We're going to have 1 over 4. Okay, 1 over 4 minus, this is going to give me 6, then plus 1 over 2. So initially what we can do is we can find the common denominator, which is 4. Okay, which is 4. Now if that's the case, then 2 there, 4 here, 1 times 1 is 1, here 1 for 4, that is going to give me minus 24, then plus, this is going to give me 2 times that one is 2. Not so. So then I can clearly see that 1 plus 2 is 3, so 24 minus 3 is negative 21. So I'll have negative 21 over 4. That is my sum. Okay, so now I've found my sum. Now I need to multiply. So I'll say my sum is negative 21 over 4. I'll leave it there. Now I need to multiply these guys. Then if I want to multiply, get rid of that. That should be like that. Alpha squared times alpha is alpha to the power 3 plus alpha beta squared. Alpha times beta, alpha beta. Not so. Yeah, then beta times, I've done this times this is this times that is that, then this times this is this times that is beta to the power 3. Okay, if that's the case, why here we have, okay, just a minute, let's do it again. Alpha times alpha squared times alpha is alpha to the power 3, this times this, yes, okay, yes. So this time this is alpha beta squared. Now we are trying to find alpha times alpha. So why I'm still having doubt here is because here I feel like, okay, let me restart it. It can't be like that. It will fail to come out. So alpha squared plus beta and alpha plus beta to the power 3 or to the power 2. Alpha to the power 2 times alpha to the power 2 it will give me what? Okay, let's see. So we are going to clearly see that it's going to have alpha times 2, that is going to be alpha to the power 3, that is going to be alpha squared times beta squared. Yes, so what I've done is this times this is this, then this, okay, this times this is now alpha squared beta squared. Yes, then this time this is now alpha beta, and this time this is now beta to the power 3. So the mistake I made was when I was multiplying this and this, I didn't include the 2. Yeah, it's now making a lot of sense actually. So then alpha to the power 3 plus beta to the power 3 plus these ones can be alpha beta raised to the power 2 plus alpha beta. So now this one, as long as there is alpha to the power 3 beta to the power 3, you replace it with that, don't forget. So it will be alpha plus beta raised to the power 3 minus 3 alpha beta and alpha plus beta, then plus alpha beta raised to the power 2, then plus alpha beta. Let's plug in the values. What is alpha plus beta? We found half. Raise it to power 3 minus 3 alpha, so here there is plus, we have, no, there's no plus. Alpha times beta is 3, alpha that is 2, 1 over 2, plus alpha times beta 3, then plus alpha beta again, so this is squared, again here 3. So 1 times raised to the power 3 is 1, 2 raised to the power that is 8, minus that is going to give me 9 over 2, plus 3 squared is 9, 3 squared is 9, then that is just 3. So what do we do? These 2 can be added, 1 over 8 minus 9 over 2, those 2 can be 12. The common denominator, I'll get 8, here there's 1, 8 there, 1 times 1, 1, so here 4 times that should be 36. Then 8 times 12, so now we have 8 times 12, that is 96. So this and this is 97, so 36, negative 36 plus 97, that is 61 over 8. So using this formula, that is now the product. So the formula is x squared minus the sum. What's the sum? The sum is negative 21 over 4 x, then plus the product, that is 61 over 8. It should be equal to 0. Now we don't leave this to have, I'll say x squared minus negative and negative will be plus 1 over 4 x plus 61 over 8 should be equal to 0. To get rid of the fraction, divide it by the number that is big on the denominator, or 2 times 8. So 8 there, I'll have 8x squared. Then here I'll have 4. 4 times 21, 4 times 2 is 8, 4 times 1 is 4, x plus here it will be 1, so it will be just 61 is equal to 0. That's the equation. Do the same for the rest of the questions, and I believe you will definitely be able to get that. Okay. So let us see. So what we have now is we do the second one, part B. First thing, do the positive one. So alpha over beta squared plus beta over alpha squared. The common denominator is alpha squared times beta squared. Beta and beta will cancel. Not so. Beta and beta will cancel. I'll have alpha to the power 3, because it's alpha to the power 2 times alpha to the power 3. Here I'll have alpha to the power 3, or beta to the power 3. And remember, beta to these things has to be replaced by alpha plus 3 raised to the power 3 minus 3 alpha beta plus alpha plus beta. Then you divide that by alpha beta raised to the power 2. Now you can plug in the values. Alpha plus beta is 1 over 2 raised to the power 3 minus 3 alpha times beta is 3, then positive 1 is 1 over 2. Divide that by 3 but square it. So that will be 1 over 8 minus, that is going to be 9 over 2. Then you divide that by 3 squared is 9. We're trying to find the sum. So we have 1 over 8 minus 9 over 2. The common denominator is 8. 1 times that 1. So here 4, 36. And I'll have negative 35 over 8. Then you divide it by 9. So which is the same as negative 35 over 8 times 1 over 9. Which gives us negative 35 over, so if I do 8 times 9, I'll end up having 72. That's the sum. So the sum is negative 35 over 72. Okay. What of the product? Let's see the product that we're going to have. We see the product that we're going to have. So we need now to multiply those. We need to multiply those. Okay. Yeah, we need to multiply those. So if we multiply, what are we going to have? Let's see. Let's see what we're going to have. So have alpha over beta squared. Yeah, so have alpha over beta squared. What do we expect to have? But do you think, have we made any mistake here? Just a minute. Let me take you back a bit. I feel like 72 is too big, but it can be. But if at all I've made any mistake, we'll be able to track it here. Where do you think we're going to track it here? Yeah, we can track it here. But I don't think I've made any mistake. I don't think I have made any mistake. I don't think so. So let's see. I don't think so. But if I've made any mistake, please let me know in the comment section, because this is just correct. This is just correct. And some giving me, yeah, this is correct. So let's now multiply. We are multiplying this and those, so it will be alpha times beta is alpha beta. That one will be alpha beta to the power 2. So alpha times beta is 3. that will be 3 squared, so that will be 1 over 9, no, 3 over 9, which is 1 over 3. Then the equation will be x squared minus, does 3 goes into 7? Yes, it goes, so it will be better. So this is correct. Negative 35 over 72x plus 1 over 3 should be equal to 0. Now this is x squared plus negative and negative is plus, 72 plus 1 over 3 is equal to 0. I'll do times, you can leave it there, but I'll do times 72 to get rid of the fraction, and I'll end up having x squared plus 72 will go, I'll have plus this, then 3 into 72, 3 into 7 is 2, then 3, so here there's plus 3 into 12 because there will be 1, so it's 24, should be equal to 0. So that is my answer. Okay, now I'm not going to do part C, try to do part C. Part C and this, it should be similar, or maybe let me do, you are going to do part C and E, me I'm going to do D and F. Okay, so let's first add. The first thing is the common denominator there. If I'm adding 1 over alpha plus, then I have 1 over, it will be the same. If I solve this and that, it's the same thing, there's no difference. So it will be alpha to the power 3 times this. Here I will end up having beta to the power 3, alpha to the power 3. Rearranging that is the same as this. So alpha to the power 3, replace it with that, don't forget. Divide it by this. Plug in the values. If we plug in the values, we end up having alpha plus beta is 1 over 2. Just to the power 3 minus 3 alpha times beta is 3. Alpha, that is 1 over 2. So this is 3 but raised to the power 3. That becomes 1 over 9, 1 over 8 minus, that is 9 over 2. So then I divide this by 3 raised to the power 3 should be 27. 9 times that, 27. So what we actually have is 1 over 8 minus 9 over 2. Let's first find this. The common denominator is 8. So here I'll have 1 minus, here 4, then 36. I'll end up having 35 over 8, but there is divided by 27. Negative 35 over 8 times 1 over 27. Okay, so what do we expect? We'll have negative 35, then 8 times 27 is 216. So that's the what? The sum. So the sum is negative 35 over 216. Then I go ahead and also find the product. I just do times. 1 times 1 is 1. Alpha to the power 3 times that is just this. So it will be 1 over 3 raised to the power 3, so which is 1 over 27. That's the product. So then I need to find x squared minus negative 35 over 216x plus 1 over 27. So in this case, you realize that there will be a number which goes into 27 and 216. So if you do 216 divided by 27, it goes 8 times. But if you don't know, you can leave it here. This is x plus 1 over 27 is equal to 0. But in most cases, In this case, I'll multiply everywhere by 216 to get rid of the fraction. So it will be 216x squared plus 35x plus now 27 into 216 is 8 plus 8 is equal to 0. That becomes my function. So you guys go ahead and do this. Is basically the same as what I'm from doing, and this. Okay, so let me go ahead and do part F. So part F, the first thing is I need first to find, even this one I think you can do, but the only thing here is just find the common denominator, which is going to be alpha times beta. So alpha times beta, this alpha is going to be, and then here we're going to say beta times alpha, it will be this, then here will be like that, then plus beta will go, I'll have alpha times alpha is alpha squared plus alpha beta, like that. Then the next thing you're going to find now is you replace, now you rewrite this, alpha plus beta can be 2 alpha beta, then those ones is going to be alpha squared plus beta squared divided by that. You know that you're going to replace this with that. When you replace that, find the sum. After finding the sum, now multiply. So the multiplication will be like this. You multiply those and down will have this. So this time that it will be alpha squared. So it will be alpha squared plus beta squared plus, those are going to be 2 alpha beta. And you know what to replace this with. Okay, this you're going to replace it with that. And this 2 alpha beta is minus, this is positive. They will cancel out and we remain with alpha plus beta in the bracket squared. When you find that, now plug in into that formula I gave you, yes, which is this one, and find the sum. So finish for F, and also I'll need the final answer. I'm going to check your answers. Okay.